Sometimes in an experiment, we encounter this lurking variable. So a lurking variable is just any variable that does have an important effect on the relationship among the variables in the study, but it's not one of the explanatory variables studied. So for example, in a study that's looking at blood pressure, then perhaps your age could be a lurking variable. Your age could certainly impact your blood pressure, but that's not the explanatory variable that's actually being studied in the experiment. We say that two variables are confounded when their effects on a response variable cannot be distinguished from each other. An example here would be something like intelligence. If you were trying to do a study about the effectiveness of a new educational review technique, you would not be able to isolate somebody's intelligence or motivation even with that study. So it will be hard to say if it's just the new review technique or if there's already something about that student that is influencing the outcome. So two variables that are so interlinked would be a confounded variable. You're always going to have lurking variables simply because of things that we can't control. We have to be careful about lurking variables when we're trying to establish this cause and effect relationship. I want you to look at these two studies to see some of the amusing issues with lurking variables. A study finds that there's a relationship between ice cream sales and shark attacks. And this really is the case. But does that mean that ice cream sales are going to increase the number of shark attacks? Well, of course not. That just seems silly. There's no way that that would be the case. But I want you to consider, when are ice cream sales up? They're up in the summer. When are shark attacks up? They're also up when people are out in the ocean swimming, which is typically in the summer. We also can look at this study where a relationship between shoe size and reading level was found in elementary school students. So does that mean that students with bigger feet are going to have a higher reading level? Well, that is exactly what this study is showing. However, what we cannot say is that students with a bigger shoe size, that is causing them to have a higher reading level. I want you to think about elementary school students. They range from kindergarten to 5th grade. Most kindergartners have a very minimal reading level. They also have tiny feet because they're 5 years old. 5th graders have established a much higher reading level because they've gone through years of school and they're older, they're 10 or 11, and so they're going to naturally have bigger feet. So here, it wasn't that the shoe size was causing the higher reading level. There was just this lurking variable of age that was influencing the outcome of the study.